And so on to the final third of the paper. This is where life starts getting a little bit more complicated, and I do apologise if you can hear in the background the noise of my dishwasher, but I'm sure we'll all cope. Okay, question 12. Figure 13 shows an algorithm represented in pseudocode, so we're still in pseudocode. The developer wants to check the algorithm works correctly. So we've got some kind of array here with 3 values in it. We've got a for loop, so definite iteration, and another for loop nested inside it. So when I is set to 0, then j will go from 0 to 1, then back, then I will go to 1, then j will go from 0 to 1 again. So we've clearly got one loop working inside another loop. So we'll just keep that up there while we bring over the question, and we're into another trace table. So this one's slightly more complicated because we've got a list to cope with, but let's see, we've got to complete the trace table for the algorithm shown in figure 13. Some values have already been entered. So I'll tell you what we're going to do. We're just going to fold this over so we can sort of try and present the two things together. That will make life a little bit easier for us. See what we're doing. Okay, so working from up here. So C is assigned into array position 0. As you can see, it's done already. B is assigned to position 1. A is assigned to position 2. C, B, A. So we're into a for loop. For I goes from 0 to 1. So I will start at 0. We move on. For j goes from 0 to 1. So j will start at 0. Now if what's in R, the array R, j plus 1, so j we know is 0, so j plus 1 is 1. So if at position 1 is less than what's in position 0, so position 1 is B, and yes, that is before C, okay, so that is true. Then we're going to do this. We're going to take what's in array position J, array position 0, and put it into temp. 0. What am I doing? C. We're going to put C in there. Then we're going to take what's at array position j plus 1, so that's what's at position 1, and we're going to move it into position 0. So we're going to take B, we're going to put it into position 0. So now you can see why we need the temp variable, because we've got B in both places now and C has just disappeared, but we've kept it in temp. So then we take what's in temp and we put it into j plus 1, 0 plus 1, that's position 1. So we're going to take temp and put it into position 1. Temp is C, we're going to put it into position 1. So effectively we've swapped the two items around. End if, so we finish the if, end for. Now this is the for here, so we're going to go back and j will go up from 0 to 1. Now we back in here again. If array j plus 1, so j is now 1, so j plus 1 is 2. So if what's at position 2 is in front of less than what's at position 1, 2 is 2, what's at position 2, which is A, in front of what's at position 1, yes it is. A is in front of C, A is less than C. So we are going to do what it says here. We're going to take what's at position 1, because j is 1, and we're going to put it into temp. So that's C again, isn't it? So we're going to take C and we're going to put it into there. To be honest with you, you could just leave it, wouldn't make any difference either way. We're going to take what's at position 2, j plus 1, 1 plus 1 is 2. We're going to take what's at position 2 and put it into position 1 because j is 1. So we're going to take what's at position 2 and put it into 1. So we're going to take the A and put it into there. We're then going to take what's in temp and we're going to put it into position j plus 1. 1 plus 1 is 2. We're going to take C and put it into position 2. So A and C have swapped over. We end if, end for. We finished this for loop because j has now reached 1. So we can move on to the end for here. We can go back. I is going to go up to 1. Now I'm going to put that down here because otherwise life's going to start getting a bit complicated. Okay, just checking we can see everything on there. Yep. Okay, so now I has gone up to 1, and remember we're starting this for loop again. So it's going to start from 0 again. So j is going to go to 0. Is array j plus 1. So j plus 1, j is 0, 0 plus 1 is 1. Is what's at position 1 less than what's at position 0? Is A in front of B? Yes it is. So we're going to do this bit again. We're going to take what's at array position j, which is position 0, and put it into temp. So we're going to put B into temp. We're going to take what's at j plus 1. 0 plus 1 is 1. So what's at position 1 and put it into position 0. So we're going to take A and put it into position 0. Then we're going to take what's at temp and put it into position j plus 1. 0 plus 1 is 1. So that's position 1. We're going to take temp and put it into position 1. B goes into position 1. I think you can see what's happening as we go along. End if, end for, we go back and j goes up to 1. J is now 1. We check, is what's at position 1 is what's at position 2, 1 plus 1, 2, is it what's at position 2 less than what's at position 1? What's at position 2? No, it's not less than what's at position 1, so we ignore that. End for, has j reached its limit? Yes it has, 1, so we fall out of that one. Has I reached its limit? Yes it has, and so we stop. And that's where we should end up. So, what's the purpose of this algorithm? As you can see, you can put down it sorts the list into alphabetical order. That'll get you the mark. What would be even better would be if you recognize that it's a bubble sort. Bubble sort is one of the two sorts you need to know, the merge sort being the other. But either of those two would get you the mark. Okay, moving on. Going over, and let's get rid of that page. Yep, done with that one. And we move on to, so we've got the whole thing here again, same algorithm. So, an earlier attempt at writing the algorithm, figure 13, has different code for lines 4 and 5. In this case we made I go from 0 to 2 and j go from 0 to 2 instead of going from 0 to 1, 0 to 1. Explain why the algorithm did not work when the value 2 was instead of value 1 on these two lines. Well, let's think what would happen if we set j to be 0 to 2. Fine first time round, and second time round. Now let's think what happens when j gets to 2. When j gets to 2, we're going to be comparing position 2 plus 1 with position 2. 2 plus 1 is 3. We'll be looking for position 3 in the array. There is no position 3. There's only 0, 1 and 2. So in that case, you'll get an out of limit error, so it just won't work. So if you put, you've only got one mark here, so you just need to write, when in your explanation, it will attempt to access position 3 in the list, and this is not there. Something like that. You're trying to access a position that doesn't exist, and that's that. Okay, remember there's only one mark, so you don't need to go crazy. Now we move on to question 13, and now the last two questions we're going to have to be looking at writing some code. A program is being developed in Python to simulate a card game. Throughout the game, each player always has 100 cards. Don't know how you're going to hold those. Each card displays a number. Players take it in turns to swap one of their cards with another random card from a set of cards until a player has a run of 5 numbers in sequence within their 100 cards. Can be anywhere in there. Figure 14 shows part of the program that will get a player to enter the position of a card to swap. So position equals int input enter a card position. Fairly standard, trying to get an integer number to ask for the position you're going to swap. Extend the program in figure 14. Your answer must be written in Python. Now when you start seeing all this kind of stuff, you start getting a bit scared. Don't worry, just wait until you find out what you actually have to do. This is actually relatively simple. The program should keep getting the user to enter the card position until they enter a card position that is between 1 and 100 inclusive. So all it's asking you to do is write a basic validation routine, making sure that when they type this, then they're typing a number between 1 and 100. So let's think about how that would be. So we'll write down there, line first, position equals int input enter card position. By the way, if you struggle to remember how to do an int input, notice that they've given you an example here, so you might want to use that further back in the program if you didn't do it properly then. Now, obviously, if they've put a number in that is acceptable, then that's fine. We can just crack on with the next part of the program. So what we need to do is we need to find examples where it's not correct. And we need to keep asking them until they do enter something that's correct. Now we don't know how many times they're going to enter it incorrectly. It might be 0 times because they've done it right the first time. So we need to use indefinite iteration to keep asking. Indefinite iteration, our best bet is to use while. So while position. Now what would be unacceptable? Well, unacceptable would be that it's less than 1. That would be unacceptable. Also unacceptable, and I deliberately left that gap, would be if the position was more than 100. Now what am I going to put in between? Now a number can't be less than 1 and more than 100, so it won't be and, but if it's that or it's that, then we're wrong. So we're going to put or. We're not going to forget our colon on the end, and we're not going to forget to indent. And basically all we have to do now is we say, well, if that's wrong, we need to ask again. If you wanted to put a print line in to say you've made an error or whatever, that's fine, you can do that. But to be honest with you, they didn't ask for that. So I'm just going to put down there the line again. I'm going to ask again. Enter card position. Not forgetting the 2 brackets on the end. And that's it. 3 lines, one of which they've given you already. All you're doing is you're going to keep asking them until they actually put a position that is in between 1 and 100, and then you can carry on with the program. Again, don't be scared by the number of lines. As long as you've actually done what they've asked, we've done enough. Now we've got a whole load of stuff here. So there are 500 cards within the game. Each card is numbered from 1 to 250, so 2 lots of each card. The player's 100 cards are always shown in numerical order. When a player has a valid run of 5 cards within their 100 cards, then they win the game. So its valid run consists of 5 cards, can start from any position in the player's 100 cards, so it could be at the beginning, middle, end. The second card's value is 1 more than the first card's value. Now there's your clue. The third card's value is 1 more than the second card, and so on, until the 5th card will be 1 more than the 4th card's value. So that is your basic way of knowing that it is so. So if we think about it, we're going to need some kind of pointer or index that's going to move up the list. And when we get to a certain point, if we can show that the next card is 1 more than that, and the next card is 1 more than that, and the next one, and keep counting until we've got 5 cards that are one after the other, then we've won. So that we stopped at the 99 card. The next one is 1 more. That's counted up to what? 2, 3, 4, 5. We win. It's as simple as that. So write a Python program to check if a player has a valid run of 5 cards. When writing your program, you should assume there is an array called cards that contains the values of the player's 100 cards. Cards 0 will contain the value of the first card. Card 99 will contain the value of the last card. The values in cards are already stored in numerical order, and there is a Boolean variable called game1 that has a value of false. So obviously we're going to be aiming to set game1 to be true. Your program should set game1 to true if there is a valid run. That's what I just said. You should use indentations appropriate, blah, 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 blah. Okay, let's think about how we could go about checking this. Okay, so game1 is set to false. So we're going to need some kind of counter that is going to count how many cards there are in a run. So I'm going to create a variable called counter, and I'm going to set that to 1. And the reason I'm going to set it to 1 is because if you think about it, everything is always a run of 1. What we're interested in do is if there is a run of 5. Now I'm going to make a for loop because I know how many items there are in my list. And I'm going to use a variable called index to remind me that it's taking me from the start to the end. Now my index is going to need to be in the range. Now it's going to have to start at position 0, isn't it? In fact, I'm not going to start at position 0. I'm going to start at position 1 because I want to check the one second in the list against the one first in the list, and so on. So you've got to think this through. So I'm going to hold off on putting out what the last number is on there until I finish thinking this one through. Now what I want to do is I'm going to want to check whether the card number that I'm at is 1 more than the card number in front. Now remember, I'm indenting. So if cards at my position index equals, double equals, remember, I always forget that, cards index -1 plus 1. So in other words, the item in the list before, add 1 to it, and it's the same as me. That means I am 1 more than the one before. So I'm in a run. If that is true, then I'm going to set counter to be 1 more. I'm going to add 1 more to my counter. If it's not true, else, I'm going to set my counter back to being 1 again, and you'll notice already I've already got that wrong. Let's put that should be over there because I should have been lining it up properly. So if that shows that the card that I've got at the moment is 1 more than the card before, then I add 1 more to my run. If it's not, then I set my counter back to 1 because there is no run. Right, so what that will do is each time we go round, it will keep checking until I get to the end, and I will but if I don't add to my run, I set my run back to being 1 again. Okay, so that will build up the run, or it will set the run back to 1. Now what I can do then, after I've done that, I can check to see, has counter reached 5? So if counter equals 5, then I've won. So I can set game 1 to true. Now notice I don't put an else here to make it go back to false, because if I've won at any point in the game, I've won. And whatever happens in the rest of the list doesn't make any difference because I've won. And that's it basically. Now where should I go up to? Well, I obviously want to keep checking up to the 99, the array position 99, and remember when we use a for loop, the last number is always 1 more than the number we want to go up to. So I'm going to go from 1 to 100. Now I could of course go from 0 to 99, and then I can be doing this by doing index plus 1 compared to index. It doesn't matter which way you do that, as long as you make sure that there is 99 between those two numbers, and that solves the problem entirely. Okay, again, don't be fussed by the fact you get tons and tons of space to write this in. You're only doing that in case you mess it up. Now we're moving on to a 2-dimensional problem, which means we're going to need a 2-dimensional list, a list of lists. Number 14, a program is being written to simulate a computer science revision game in the style of bingo. At the beginning of the game, a bingo ticket is generated with 9 different key terms from computer science in a 3x3 grid. Blah 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 blah. Player will be prompted to answer a series of questions. The machine matches a key term. Player's bingo ticket, the key term is ticked off. Okay, so far so good. So basically, if you get the answer and it's in here, your item is ticked off until you've filled up your bingo card. Right, so far so good. Now, figure 16 shows an incomplete Python program to create a bingo ticket for a player. The program has used a 2-dimensional array or list called ticket to represent a bingo ticket, and you'll see there that the way we do that in Python, as you've learnt, is that we put a lists inside a list. So you've got a list of individual lists, and we can refer to those by using 2 indices. Effectively think of them as X and Y coordinates. The program uses a subroutine called generate key term. When called, the subroutine will return a random key term, blah 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 blah. Complete the Python program by filling in 5 gaps. Line numbers and all that. Right, so here's our ticket. It contains nothing at the moment, so you've got 9 blank strings in there. I equals 1, so this is obviously 1 index. We've got I as an index and J as an index. Now here's your classic way of working your way through a 2-dimensional list, 2-dimensional array. You always will use 2 indices, one of which will go one way and one of which will go the other way. So I and j, so I will increase until it gets up to 2, j will increase until it gets up to 2, going the other way. So nice clue for you, I equals 0 it says, while I is less than 3. So what do we reckon is going to happen with j? Where will j start? J will start at 0 as well. Now, we need to generate a key term and put it into a relevant position in the ticket list. It's a two-dimensional list. How do we know which positions to put it in? Well, I and j are going up and gradually, so this will work by j starting at 0, then to 1, then to 2, then 3, and then it's time to stop. Then I will go up to 1, then j, 1, 2, 3, and so on. So we're going to be putting this in at I and j are the two indices of the array. Now, what's going to happen to j after we do that? We're in the while loop, which is encompassing j. Well, obviously we want j to go up by 1. And when this, so first time round j is 0, now it's 1, now it's 2, now it's 3, so it's not less than 3 anymore, so on we go. What we're going to want to do with I, we're going to want I to go up by 1. So now I is 1, back we go, j goes back to 0, 0, 1, 2, down to here, I becomes 1, 2, sorry. Back we go through, j, 0, 1, 2, and I becomes 3. Back we go, time to stop. So we'll have filled in I is 0, j, 0, 1, 2, I is 1, 0, 1, 2, I is 2, 0, 1, 2, finish. And so to the end. Last question on the paper. Each time a player answers the question correctly, the tickets array is updated. If their answer is in the tickets array, then it is replaced with an asterisk, like this. Write a subroutine in Python called checkWinner that will count the number of asterisks. The subroutine should take the ticket array as a parameter, count the number of asterisks in the ticket array, output the word bingo if there are 9 asterisks. Output the total number of asterisks if there are fewer than 9 asterisks in the array. Okay, so let's take that one thing at a time. Right, we need a subroutine called checkWinner that takes the ticket array as a parameter. Now I'm going to work on this big blank sheet here rather than the little bit at the bottom, but as we've said before, don't be frightened. It won't. The fact that they've got so many lines on here. Def, remember, is how we create a Python function, and we're told we've got to call it checkWinner, and it has to take ticket as a parameter. Colon, and don't forget now, everything after this will be indented. Okay, next requirement, count the number of asterisks in the ticket array. Okay, now we've had a clue before. We had a clue by the fact that we know that to work our way through the array from beginning to end, we could use I and j with while and while. So why don't we do the same thing again if we want to work our way through? So what we'll do is we will start with, don't forget to indent, I equals 0 while I is less than 3, j equals 0 while j is less than 3, and that will make us work our way through the list. Okay, we've got to then, according to this, we've got to count the number of asterisks in the ticket array. Now of course I've made a mistake already. we need to set a count at the beginning, so you need a line in there. This is why they give you so many lines to work with. I'm going to put count equals 0. You might want to just at this point, once you, like I have, just realised that you're going to be counting something up and need a count variable, you might want to just cross that out and just write it all back out again, just to make sure that everyone's absolutely clear. They'd understand if you did that. So now we need to check what is at that position. So if ticket, so if ticket ij, so ticket ij equals asterisk, what do we do? Well, if ticket is asterisk, then we're going to add 1 to count, aren't we? So all we're doing is working our way through the list. So we've done that, so now we're going to add 1 to j, which will make it, of course I forgot, didn't I? Double, you were shouting at the screen, weren't you? Double equals, yeah, I always forget that. So there you go, double equals there. J equals j plus 1. Okay, that's dealt with the j part. Let's go back to here. Let's deal with the I part. So this bit here, from here down to here, will work its way through with I going up, and within the I, j will go up one at a time. Each time, when we know our I and our j, we'll check, is the value at that position equal to an asterisk. If it is equal to an asterisk, we'll add 1 more to count. So that's the purpose of all that part there. Now, once that's finished looping, so that will go round, so the I will go round 3 times, and each time the j will go round 3 times, so that'll be 9 altogether, 3 times 3, and we'll have checked all 9 positions, and we'll have added up our count. So if at the end of all that, count equal, remember this time to write the double equals, if at the end of that count equals 9, we are told in our thing that if the count is equal to 9, we output the word bingo. Okay, so if count equals 9, we print bingo. Else, because it does say, it also says that, whoops, there we go. It also says output the total number of asterisks if there are fewer than 9. So if the alternative, if the count is 9, we print bingo. Otherwise, we print, now you could write a fancy sentence if you like. I'm just going to put print count. And that is it. We don't have anything to return from the subroutine, so we can leave it at that. And you've now completed the whole of the paper. Well done.